So I have this series on my channel called Code Review. Pretty simple concept. People send me code and I review it. It's more of like a fun kind of, let's take a look at some code and I'll give my opinion kind of thing. Now, last time I did this, someone sent in their university assignment. I'll have that video linked up there. And this was like such a interesting university assignment, to say the least, that I mentioned that maybe I should just rewrite it and just do it my way. And of course, everyone wanted that. So here I am, sitting down to do a university assignment in, I think it's been at least 5 years since I've done any university assignments. So the plan is pretty simple. I have the assignment here in front of me. I've kind of taken it and rewritten it, basically paraphrased it, because I don't want to give away the identity of the university or anything like that. And we are going to give ourselves like, I don't know, this really shouldn't take longer than like an hour, but I'm going to basically go through this, talk about the requirements, and then implement this as best as I can. Now, a fair warning. What I'm looking at is a real second year university assignment. I think the subject is called something like data algorithms and patterns or something like that. This is the exact same assignment that we looked at last time we did a code review. Like this is it. We're going to be doing that exact one. The reason why I'm being so specific about this is because this is in my opinion, quite an odd university assignment. But hey, it's a real university assignment that someone actually did and sent in the code for. So I'm gonna do that. What I haven't done is like handpicked the best university assignment I could find, the one that would maybe demonstrate the most value to you or would be easiest for me to do. I'm just doing the one that we looked at, and I never planned to do this assignment when I did that code review. So just a fair warning, this is about to get interesting. So before we take a look at all of these requirements, I want to mention that this video is sponsored by Skillshare. So for those of you who don't know, Skillshare is an amazing online learning community where millions of creative and curious people from all around the world come together to learn new skills. It's honestly, in my opinion, one of the best skill sharing platforms on the internet. I mean, it's literally called Skillshare. They've got so many classes on pretty much any topic you could think of. Anything from creative topics such as like videography, photography, editing, illustration, all the way over to like business and marketing and productivity. They've also got excellent courses on how to make YouTube videos. I really like this one by MKBHD. As a C++ programmer, I am pretty much all about efficiency, and I think Skillshare does an excellent job at that. Skillshare's videos are really well made, and they're really kind of well timed. They're like these bite-sized chunks that you can just watch when you have a spare 5 minutes. You don't have to wait till the end of the day and allocate like an hour or two to just spend on this thing. You can just consume it kind of on the go. Coming in at just under $10 a month for an annual subscription, I think Skillshare is fantastic value, but also the first 1,000 people who click the link in the description below will receive a 1-month free trial. A 1-month free trial of Skillshare Premium is plenty of time to explore the platform, see what they've got, and see what courses you like. So go ahead and click that link in the description below, check out Skillshare Premium, see what they have to offer. Thank you again to Skillshare for sponsoring this video. Now, this university assignment, let's take a look at the requirements and then we'll kind of talk about our strategy for implementing this. Okay, so I just spent a little bit of time going through the actual assignment requirements, that whole kind of sheet, and then rearranging them into this kind of dot point format that we can take a look at together. So the first thing is, the assignment's gonna be marked automatically. So it's gonna be put through like a bunch of test cases, as we'll see in a minute. Failure to follow this guideline will result in 0. So they're pretty serious about these requirements. Exactly one file, main.cpp, no design documents need to be submitted. And the task is basically to implement a very specific hash table. So this hash table, as I mentioned in the code review video that we did last time, it's not exactly a hash table even. I mean, you can't just put in a certain key and then expect to get a value out. The key that you put in, it's more of a hash set really. And I mean, hash set is kind of pushing it. But basically all it is a storage of 26 English words, as we'll see in a minute. And the word can either be in there, in this data structure, or it cannot. So there is no kind of associative array. I can't, put in a word and get another word out. That's what a hash table would be. So, I mean, it does say it's a very specific hash table, but I think that one thing we can take away from this assignment, and assignments like this assignment, is that It is in fact very specific. It's unlike anything that I've actually seen in the real world, which first of all does kind of, kind of brings up the point of, is this even useful? But I think in a way it is, because this assignment is a good example of getting you to actually follow requirements, because it needs to be done exactly in this way. So this very specific hash table, what is it? Keys are lowercase English words, so like apple for example. Length of a key is at most 10, so like words under 10 characters. The hash function is, and this is a quote, simply using the last character. Example, the hash of apple is E. So if we put in a word like apple, the hash is in fact E, which means that obviously if there's, I don't know, apple and orange, those are two words that end in E, there will be a collision. But of course we can deal with collisions, as we'll find out in a minute. The hash table contains exactly 26 slots, A to Z. By the way, if you're following along with this at home, try and write down these requirements and implement this for yourself. I think it'll be a good exercise, and then we can compare our solutions in the end. You won't need more, because of course this is designed to just go through the test cases. It's marked automatically. If it goes through the test cases, you win. That's not to say we should maybe hack this and just produce something that isn't even a hash table, but you know, that is possible. Table slots have 3 different statuses: never used, tombstone, or occupied. So the fact that these are here and in quotes, to me, basically says that, okay, so we have 26 slots, they have to be strings. They have to be either never used, tombstone, or occupied, because, I mean, I guess fundamentally they don't need to be strings, but it seems to imply that they should be strings. Table starts with never used. So basically, I guess in the beginning we initialize 26 slots, all with never used. Searching works as follows. So given a key, take its last character as the hash value. So if we enter a key like apple, then E is in fact the last character. First try the corresponding table slot. So each letter in the English alphabet, A through Z, has a table slot. So we could basically have an array where it's like from 0 to 25, and then we just need some kind of conversion function to convert from the letter into the table slot. I mean, it's just really just, we could use it as an index. If the key is there, you found it. If it's never used, it doesn't exist. So if we put an apple and we get back never used, it never existed. If the key is occupied or tombstone, then move to the next slot. So if we're trying to look for apple and we get occupied and it's not apple, or we get tombstone, then we try and move to the next slot, and we may need to like wrap the table. So if we're at slot 25, we'll go back to 0. Keep trying until key is found, or we're certain it doesn't exist. So at worst, this is just going to search the entire table, basically. I mean, it's kind of unlikely, because if we run into never used, then it doesn't exist. So unless the table is literally full and we don't have that key, we're not going to search everything. Keep trying until key is found, or we're certain it doesn't exist. Yep, insertion works as follows. So first perform search to see if the key exists. If it does, then do nothing. Take the last character of key as hash value. So we get, if we're trying to insert apple, we take E. If that slot is not occupied, put the key there and occupy the slot. If it's occupied, try the next slot until you find a free slot. So this is the collision kind of management. So what happens is, if we already have apple in the list, I mean, I'm even accidentally calling it a list instead of a hash table, because that's basically what it is. But if we have apple in there already and we're trying to insert orange, they both end in E, we end up in that same kind of index. But what we do is we just go forward an index. So we effectively put it into the slot of the letter F instead of E. Now, according to these requirements, if it's occupied, try the next slot until you find a free slot. Until you find a free slot. So if there is no free slot, this will just go infinitely. And I'm pretty sure that's what the assignment that we looked at did. It just happens to be that none of the test cases happen to use more than 26. And I mean, the assignment does say that we have exactly 26 slots and you won't need more. So if you won't need more, then I guess this is fine, because it should never run into a problem where it just can't insert the value because there's no free slots, since at most we have 26 slots and 26 possible inputs. Deletion works as follows. Given a key, search for it to locate its slot. If it doesn't exist, do nothing, and if found, change to tombstone. So it doesn't really say what to do if, so I guess if you run into a never used, then clearly it doesn't exist. Tombstone would mean you go to the next slot, because there could have been another key there. But then also, if you get occupied and it's not the key you're looking for, then you also move to the next slot. So I wonder what would happen if you tried to delete a key and then you tried to delete that same key again. It would probably go through the whole table and not find it. But then the search function, keep trying until key is found or we're certain it doesn't exist. So the search function needs a way then to basically terminate if it has in fact searched everything and it couldn't find it. Again, very unlikely because we will run into a never used unless the hash table is full. So I guess we can ignore that. When program starts, init empty hash table, so 26 never used slots, okay. Command line input is 1 through 26 modification moves, separated by spaces. So moves are a word, which is the character A, followed by a lowercase English word of up to 10 characters. So a apple means insert key apple into hash table. Same with D, except D is for delete. So delete apple from hash table is D apple. Once input is processed, output is all the slots in the hash table that have occupied values separated by spaces. Ignore invalid inputs. So if the input is malformed, we just ignore it. Okay, so sample input is this, A apple, A orange. So we've added apple and orange, and then we've deleted apple, and then we've added strawberry, and we get orange strawberry, which is what you would expect. Submit via SVN, and then marking done automatically. Total mark is 10, 1 for compiling, and then 9 marks for 9 test cases. And it's also compiled using G++ with C++ 11, optimization 2, warnings all, main.cpp. So obviously we have to provide a main.cpp as it mentioned above, and then we also have to make sure that we are in fact only using C++ 11, and that it compiles with G++. So that's obviously the compiler we're going to use for this assignment. The sun is really creeping up on me. You know, I didn't really plan for this to be this in-depth. Let me know what you think of this kind of this kind of video. I was going to just skim through it in like 10 minutes, but there's just so much here to unpack. So I'm probably going to skip the whole designing this stage. I mean, the assignment mentioned we don't need to submit any kind of design document. And also, I think this video is dragging on long enough, so I'm probably just going to jump into the code and start programming this. At its core, I think it's quite simple. It shouldn't really give us too much trouble. There's just a few particular cases and, you know, I mean, I don't really want to change this too much. Like, you know, it says table slots have those kind of never used tombstone or occupied statuses. I could make that some kind of enum or an integer or just like something like that. I don't think I will. I'm not really going to be focusing on performance here. I'm just going to try and implement this as best I can based on these requirements, and obviously so that it actually gives us our output correctly. Okay, so as we dive into this, let's take a little bit of a look at my setup for this assignment. So I basically have just made a folder. I've opened up Cygwin, and then the reason for this is because I just found this on my computer and it happened to have G++ kind of in the path. I didn't really have this in command prompt, so that's why I'm using this, just so that I don't have to like add it to my path or do anything crazy like that. You can use anything you want because the only reason to use this terminal at all is for the actual compilation. Now, if we take a look at the university requirements, they're pretty specific, meaning that we need to use basically this exact command to compile our code. If we don't do that, then there's a possibility that, of course, it won't compile, like if our files are not named correctly or something like that. It just won't compile, obviously, on the automated testing. And when you're dealing with automated testing, you need to make sure that everything works exactly the same way that is going to be automatically tested. I don't want to get 0 for this assignment, so we have to use this. Now, instead of typing this all the time, it makes sense to kind of put this into like a little bit of a batch file. Now, I don't think that like, we're not going to be the ones running the command. We don't need to write a file, like a script for the server to execute or whatever. They're going to be running the command. So this is just for us, and we're on Windows. So I'm just going to touch a file here called like build.bat. And then inside that build.bat file that we've just made, let's go ahead and drag it here. And then we can paste in that command. That's all we're doing. It's just so that instead of actually having to run that command every time, I can just call build.bat. Like this. Please help me. Now, if it's giving you a permission denied, it's because this is like a kind of Linux E terminal, I guess. And so we have to actually do a chmod plus X to make it executable. So let's go ahead and do that. Not technically required on Windows. We can, of course, just run it normally. But to run it through this, it wants that to be happy. Anyway, there we go. So we don't have a main.cpp file. So let's quickly just touch that in here. And now we can just drag it into our VS Code over here, and we can just edit that. Let's just try compiling it. I mean, obviously it's not going to really do anything. Oops, I touched it again. Let's go back and run build.bat. And then, I mean, we don't have a main function or anything like that, so it's not going to do anything, but obviously it's sending the right file to the compiler. So the first thing I always do in these cases, I mean, always, is just make sure that my tool chain is set up correctly, especially when compiling from the command line. So all you have to do for that is include like IOStream and just try and print something. So I'm going to go ahead and print hello like this. And then if we go back to our Cygwin over here and try and do build.bat, you can see that it compiles and it gives us a main.out. If I run this main.out, then we get hello printing and everything as well. Now, to make this a little bit easier, what I can do is actually call build.bat and, so double ampersand, and then main.out, and that way it will compile it and then run it immediately. So this is kind of nice when we're testing if you don't want to set up like a whole thing through VS Code, because I don't really care about that, to be honest. Okay, so moving on to the actual code. I'm going to be referring to the assignment requirements pretty heavily for this. I have them on my other monitor, so I'm not going to show them all the time. If you want to look at them, you can go back in the video, but I will highlight certain things. So the first thing that I actually feel like starting with is the input processing. So we know that based on what they've told us, the input can either be like a word or D word, basically. So if I copy and paste stuff from the assignment sheet that I made earlier, then you can see we have a apple, a orange, and in fact, let's go ahead and copy the sample output. So if we start to take a look at this input, I basically just want to make this command parsing work. Why? Because it's going to be the foundation for testing the rest of the application, and I like to iterate frequently and test pretty much all the time. So how are we going to be able to parse this input? So we know that we have one character here, A or D, that's going to be basically one of two commands. So we clearly need to determine whether or not the command is to add or delete. But before we do that, we also need to be able to take in a string like this and separate it by each space. Lots of different ways to do this. I think the most straightforward way that is also obviously supported in C++11 is just to use string stream, honestly. So what this means is that if we wanted to take a line in, which it seems like if we look at the requirements, they're not actually command line arguments. The sample input is literally this. It's not like, you know, running the application and then passing in everything as command line arguments. So we're not going to be using those. We need to actually be able to take in input from stdcin. That's how I interpret it, and that's also how the assignment we looked at during the code review did it. So because of that, let's go ahead and just basically write our input here. We'll use the getLine function to just get that input line from cin. This obviously gets our entire line. And then what I want to do is actually feed this into string stream. So if I go std string stream ss, with that input string, what I can do now is just keep pulling out tokens from this. So if I write a while loop that continues basically as long as that string stream still has tokens for us to process, we can simply pull out the token by using this kind of bit shift right operator here. So now we should just have a list of tokens basically. So let's go ahead and try and print them just to make sure everything is working successfully. And you can see we basically have most of our input parsing sorted already. Very easy. So I'll save that. By the way, we do not need a return 0. That's not really required. Although now that I'm thinking about it, maybe it is in C++11. Maybe that's a newer feature. But no, actually we would have gotten a warning, especially with warning all. So the main function is special in the fact that even though it returns int, you don't have to return anything and it will assume you're returning 0. So let's go ahead and run our little command once again and we'll see what we get. So okay, so it's waiting for input now. So let's go ahead and copy this input that we'll be using as our little sample input for now. I'll paste it in and run it, and you can see we get every token here on a separate string. So that's immediately done. I mean, you can see how quick that is. Really, really easy to use, and no need to like go through every character, look for spaces, anything like that. We can just take advantage of the C++ standard library that was available to us back in the day. Back in C++11. Okay, so moving on, now let's go with the kind of second part of the input parsing, which is what do we want? Like to add an element in, to insert an element, or to remove an element. So to do that, we just simply need to, for each token, so our token obviously is going to be like this, for example. For every token, we just check the first character. So in other words, if that first character of the token, so token 0 is equal to A, right? And remember, it has to be in this format. It has to be uppercase. This has to be lowercase. Everything's very much set in stone. So it's really easy for us to do our jobs here. If token equals A, then that's kind of it. Else if, so there's no reason for us to check it again. So we can just use an else if. We can go over here and check to see if it's D. And so basically this means that we have an add command and we have a delete command. But then we have the next kind of stage of this, which is kind of, okay, so I've got my add and delete commands, but what string do I send to that command, right? Because we obviously don't want to just take the token and send it because the token is a apple. We are interested in this. So what is the easiest way for us to actually take this, I guess, take this token and just trim off that first character? So a few ways come to mind. The simplest one, probably using the standard library, is just to use substring. So if we go ahead and say like std string, and I guess this is like entry name, we can just set that to like token.substring, so subster1. And then that will automatically go to the end of the string and starting from the first character. So that's definitely going to work, I think. So if we go ahead and, well, let's kind of set this up. So we'll do stdc out, and then we'll say add, and then I'll print the actual entry name that we're trying to add here. Notice that I've written this let's quickly add that end line in. Notice that I've written this up here. I'm not doing it in each if statement because it applies to both. And if we give an invalid input, then it doesn't really matter anyway. So let's go ahead and go back here and see what we get. So I'm going to go ahead and paste in my input. And then you can see we have add apple, add orange, delete apple, and add strawberry. Let's for fun put in like some inputs that are just a bit weird. So I'll put these in, but maybe the first, oh no, I've ruined something. Let's try that again. So if I paste in like this input, for example, but let's just add Cherno, which is a bit weird. Oh, thanks for overriding everything, but whatever. Then you can see it just simply ignores Cherno. It just goes with, well, actually add apple still. And then Cherno's here. This is just, I think this is just Sigwin being weird. So let's go ahead and run that again. So let's just type in hello, a apple, D orange, which doesn't exist, and then some random stuff. You can see out of that, it only took an add and delete because those are invalid commands. Okay, so it ignores all the other ones, which looks like it works fine. The other way that comes to mind that isn't really required is we could just use the constructor of std string that takes in like a const char pointer. So in other words, if we were to get like this character from it basically, right? Except set this to be the memory address of the first character of this, which is this, the memory address of this. Since it is just a string buffer, we can also do that, I assume. I'm not gonna lie, that actually came to mind first because I'm usually thinking about memory and stuff like that. But you can see that we get the same kind of result. I would probably leave it as substring just because it probably makes more sense to most people. Okay, brilliant. So we've got the entry names. We've got all of the input parsing done. It ignores everything. It's very clean, at least in my opinion. So let's go ahead and talk about the actual hash table now. So the way that I want to write this, because we have some fair initialization code that we need to do. Remember, we have to fill in 26 slots with the status of never used. So I'm actually going to write a class for this. It's not really required to do this. Of course, you can write this however you like, but I'm kind of thinking of it as a class, and I want to keep it organized under a class. So what we're going to do is write a hash table. To be honest, the constructor I think is probably just going to be a default constructor. And then this is going to contain a bunch of entries. And this entry struct I'm going to create in a minute, but each entry is going to contain the actual data that we're storing as well as the status, because those need to be stored separately. So we're going to go ahead and I guess I'll just call this entries, and we know we need 26 of them. Rather than writing 26, I'm probably going to, let's make a little, so I can't use constant expression, const expert, because that's not a C++11 thing. So let's go ahead and just make a static const int. I'll call this size. So this is inside the hash table namespace. So clearly we're referring to the hash table size, and I can just pass in size as long as it's const. G++ probably accepts non-const like stack allocated array things as well, but whatever, we'll leave it as this. So let's go ahead and create that entry struct. Again, I'm going to create this right within the hash table like this in the public section, because we don't need to pollute the namespace or anything, and I don't want to call it hash table entry. It fits perfectly inside this class. Again, I'm just using this as a bit of an organizational thing. So we have the data, which we're storing, and then the status as a string, which feels a little bit a little bit wrong to me to store status as a string, but again, we're following the assignment directly, and it's not really going to make any difference if we really think about it. If you spell everything right, and you're not going to have like thousands of string comparisons, which isn't going to happen. Okay, so anyway, we've got this. We've got our 26 entries now. Let's go ahead and actually fill out these commands. So the first step that it actually says, by the way, is to initialize everything with never used, which I've actually already done, right? So entry creates 26 of these. They get initialized with never used. So technically speaking, we should already have 26 never used entries just by doing this. We don't need to manually iterate through everything. And to kind of demonstrate this, I'm going to write a print function, which we need anyway because the output needs to be that. And that's basically going to go through and just output all of the entries that we actually have. But for now, what I'm going to do is actually go through every entry and just print everything, mostly for debugging. So I'll go through all of the size here. And then basically what I'm going to do is just do std cout, and then we'll do m entries I, and let's just print the status of the entries for now. And I mean, I guess it makes sense to also do the data when we're debugging and stuff like that. So let's do data, and then maybe like some kind of bracket over here, parentheses, to actually print the status and obviously the data here as well. So let's go ahead and just run print basically. So I'm going to go ahead and actually create the hash table. It doesn't really matter where we do this. Let's just do it like maybe over here. So we'll go ahead and say hash table, and then after we pass all the input, I'm just going to go and do hash table dot print, which will eventually become the print function of printing it in this format, which is what we require. So let's go ahead and run that. I will paste in my my test kind of case. And then you can see that we already end up with no data in any of them and just 26 never used slots. So everything looks like it's working pretty well. Okay, so the next stage is to add these functions that are going to add or delete our entries. So we don't actually need these because I'm just going to call hash table dot add, and then I want to pass in the entry name. So we have add and delete. Could call this insert, but we'll call it add for A. Let's write these functions. So up over here, void add. Now we're using, okay, so I probably would take this in as some kind of string view, but since we are using C++ 11, which doesn't have that, I'm just going to take it as a const reference. So const std string, entry name, we'll call it, maybe entry string, because it's not necessarily a name. Might go over here and rename it as well for consistency. Not that any human is going to read this assignment, apparently. It's just going to be all done through an automated testing little program, so great. Anyway, so we have add and delete. So what is add going to do? So let's take a look at the requirements. So to add, we first need to perform a search to see if the key exists. So what that means is that we need to look at this first. So given a key, take its last character as the hash value. Let's focus on that first. So what I'm going to do is actually write a find function, which I guess will return like a boolean, whether or not it actually finds what we're looking for. Now, if I'm being really like pedantic about the organization, I guess I would mark this as private. I like to make a separate private section for functions versus members, by the way. So we'll have a find function that takes in some kind of entry string and looks for it. But obviously, in order to actually find it, we need to first be able to hash it. So I'll call the hash function getIndex because that makes a little bit more sense to me. And I guess what we'll do is we'll just accept in a string and we'll get back the index into this array that it should belong to. So how do we calculate the index? Well, the hash function, remember, is just the last character of the string. So entry string.back gets us the very last character. No need to do something like entry string.size -1. You can just use the .back function and it will get you the last character of that entry string. But now, how do we map that into an index here? I mean, we know that if the character is A, and it is in fact through from A to Z, A should probably map to like 0 inside here, and then Z should map to 25, which, I mean, it won't at this case. So how do we write a conversion function? Well, the way that ASCII works, obviously, is that every character actually has like a numeric value. And if we take a look at like ASCIItable.com, for example, we know that the lowercase letter A has a decimal value of 97. So if we were to take the last character like A, which is actually just an integer with the value 97, and subtract 97 from it, we get 0, which is exactly the spot for it. Similarly, if we get the second character B and we subtract 97 from it, is 98, we get 1, which is slot 1, all the way down to Z. If we subtract 97 from 122, we will in fact get 25, which is the correct value. So all we have to do is subtract the numeric value. Now that's really, really easy to do. There's no need to like create some weird switch statement that goes through and like, tries to map, A to 97. It already is that value. So all we need to do is take entry string.back, which is a char, and subtract another char from it, like A. And that will subtract 97 from whatever the character value here is. Now, of course, if we abuse this and put in uppercase characters or symbols, we will probably get a crash because it will not be in the bounds of the array. But that's not what the assignment requirements state. So that's all we'll do. We just have to return entry string.back minus A. That is our entire hash function. Pretty easy. So now that we've done this hash value key thing, first try the corresponding table slot. If the key's there, we found it. If it's never used, it doesn't exist, so we can return false from our find function. If the key is occupied or tombstone, then move to the next slot. And keep trying until the key is found or we're certain it doesn't exist. Pretty simple. So all we have to really do is go through basically every slot, check to see if it's actually is equal to the string that we're trying to search for. And then if it is, return true. If it's not, and it's never used, return false. Otherwise, we can obviously return, otherwise we just keep going basically. So let's go ahead and start by probably declaring some kind of index, which is going to be the ideal index of entry string. So we can do that by just running our getIndex function with the entry string. And then we can just write a little while true loop to make this kind of easy. Now, it didn't say anything about terminating after a certain after a certain kind of amount of iterations, or if we can't find the string, because remember, we'll never have more than 26. So it's a little bit, I probably wouldn't write this in real code, but for the assignment, it's totally fine. So what we'll do is check every entry. So now we're at this index. So we just need to check entries at that index to see whether or not the status here is, well, let's just go with never used first. So if it's never used, and it's not equal to what we're actually looking for, then we know we can just return false. But obviously before we do that, we actually need to see if this index contains what we are looking for. And we can do that by just doing mEntries.index.data equals that entry string. And if it does, then we found the string and we can return true, even though I'm writing false for some reason. So there we go, return true. If it's never used, we return false. And then obviously the last thing to do is actually increment the index. Now we can't just increment it because because it needs to be able to wrap around. So instead we can just set index equal to index plus 1, mod the size of our table basically, and that will wrap around. If it's 25, it'll go back to 0 when we try and add 1 to it and then mod it. So that's pretty simple. If we somehow get to the end of this, this is unreachable code, but we'll write it anyway, return false. Again, I would really make this terminate after like 26 iterations, but whatever. So let's go ahead and try that out, I guess. We'll try and find something that has been, we can't do this yet because we haven't added anything. So the first step is to try and see if the key exists if we're inserting. If it does, do nothing, okay? Otherwise, take the last character of the key as the hash value. Obviously, we have our getIndex function. If that slot is not occupied, put the key there and occupy the slot. If it is occupied, try the next slot. So immediately, let's implement the first stage of that. Let's go ahead and just write a boolean called exists. We'll call find on entry string. So if it does already find it, so we're trying to insert something that exists, we can just return basically from the function. Otherwise, let's take a look at where to add it. So now I'm thinking like, okay, we've searched this. This already goes through the loop. We could write another function that basically tries to find the next available spot for insertion. And I think I will do that. The other idea that came to mind that we might use for something else a little bit later is actually taking in a parameter that is our kind of out insertion index. And that way, when we do stumble upon a never used or a tomb slot, just since we are actually iterating through this, we could just immediately set out index to that first index. But I think it will probably make more sense to just write another function, which is something like find, or something like get insert index or something like that. So get insert index will find the first available place where we can in fact insert entry string. And so what it will do is, again, it needs to see what the ideal index is. And now it's just about seeing what is currently at that index. Because if there's nothing at that index, so if it is in fact never used, then we will in fact just return this index since we can put it in there. And in fact, it's not if it's just never used, it's also if it's tombstone, because it's that, you know, an object has been deleted and the requirements state that if it's tombstone or never used, then obviously that's a valid insertion index. Otherwise, we basically keep going. So in other words, if the status is in fact occupied, then we keep going until we find a suitable index. So this will return an int instead. Well, we're obviously returning index. Otherwise, I don't know, we can return -1. It doesn't matter. This is a while true loop, and anyway, we won't get into that. Also, this is another really good case for why string comparisons are just a really weird idea for this. You know, we have to type this perfectly, otherwise it's not going to work. And also, we are literally just comparing character by character to see if these are equal. I don't know why we're doing that. Comparing an integer like via an enum would be obviously a lot better, but we're doing this way because I like pain. Okay, so now we obviously can scroll back up here and just see what our kind of insert index, I'll call it, is. So we'll run get insert index with entry string. That should give us back a valid index. And then all we have to do is do mEntries insert index. We need to set the data to be our entry string. And then we need to set the status to be occupied. And I think that's probably it for the add function. Let's go ahead and test this. I'm a little nervous because we've written a lot of code. There is no, like, you know, IntelliSense or any kind of error checking inside this text editor. So let's go ahead and just run that and see if it even compiles. Okay, it did somehow. And let's go. Oh, well, actually, I'm not adding anything, am I? Oh, no, I am. So let's see, because it will in fact print it. So let's copy our example case and see what happens. Obviously, delete doesn't really work yet. Okay, so what do we have? We have Apple occupied at slot, what is it, 0, 1, 2, 3, 4. So A, B, C, D, E, and it does in fact end with E. That's occupied. Orange is occupied at the next available slot because it also ends with E. Remember I mentioned it would take the F slot. And then strawberry is occupied at the Y slot because this is obviously Z. So looks pretty good. Obviously deleting doesn't work, but I think we were able to validly, I don't know if that's a word. We were able to insert properly all of our kind of elements that we tried to. Let's make delete work. So what does delete do? So delete basically does something similar to this, right? I mean, it tries to find whether or not this entry string exists. If it doesn't exist, then we return because there's nothing to delete. But otherwise, we need to actually like find the index of that actual entry, right? So this is where I am actually going to modify the find function. So the find function returns true or false. I could get it to return an index, and then we could check to see if the index is -1, which means it didn't find it, something like that. But what I'll do is instead I'll take in an integer by reference, which is going to be out index, right? I'm labeling it as out so we know it's an output parameter. But basically what this is going to be is, in the case of the fact that it does in fact find what we're looking for, it's going to set the out index to be whatever index that happened to be at. So now it gives us a little bit more information. It doesn't just tell us whether or not the entry string exists, it tells us where it exists. And that's perfect for a function labeled find. So now what we can do, and that's really, I think, all we need to do, because this returns false, we don't care about that. So if we go back up here, we'll have to add it into here, even though it's unused. So I could, you know, just label this as index or even unused if I wanted to. By the way, I could make this a pointer, and that way it's null by default. And if it's null by default, you don't have to use it that way. You know what? I've already shown you guys how to do it this way. I might as well show you the other way. So the other way would be if we make this a pointer instead, set it to null pointer as a default parameter. And then what we could do is set out index to index if it's actually valid. So if it's not null, we'll set out index to index like so, dereferencing it, copying the value into that output parameter. And then over here, that means we can still, for this case, we can call it with no parameter. But then for this case, we can in fact make an integer called index and then pass that in like so. So let's go ahead and compile that and make sure that works. Okay, it does. I'm not going to lie. I was slightly scared that default parameters weren't supported in C++11 for some reason. I think I'm thinking of like C++98 or something, way older than C++11 or C++03. Anyway, so delete. So if it doesn't exist, we return. Otherwise, we've already got the index of deleting it. So what do we do? Well, really, all we need to do is mark for that particular index the status as tombstone. Now, we could clear the data. Doesn't really tell us that we have to. And obviously, if it's tombstone, when we write our print function properly, it's not going to print it. It's only going to print occupied slots. So we don't really need to worry about wasting time changing the data. That's kind of it. The one thing I will do to these two functions is I'm going to change the if statements, because at the moment, I mean, we have a return here, and we also return, obviously, when we get to the end of the function. Multiple function returns can be a little bit confusing. If this was a huge function, I would definitely leave this here, because I don't like to put massive, bodies of like if statements and stuff like that. But for this, because it's only 3 lines of code, and here it's even shorter, it's just 1 line of code. What I'll do is I'll say if not exists, right, then we can add it by just basically putting this inside the if statement, like so. And then here, if it does exist, let's just delete it like that. So this makes it a little bit more clear, and that way we know where we exit the function. It's going to be in the same place. I think that is possibly it. So let's take a look at this again. Can't believe we're getting no compile errors. I mean, I'm just writing this and no errors. Look at that. So where's our example cases? Here they are. Paste. Okay, so we didn't crash, which is nice. Okay, so apple has been set to tombstone, right? Because we added apple, we added orange, we deleted apple, and then we added strawberry. So apple has in fact been changed to tombstone. Now, here's another test actually. Tombstone should be a valid parameter to use. So what happens if I do apple orange and then let's add something else. Grape is also a fruit that ends in an E. So let's go back and try and add that in, because it should occupy that slot actually. So that'll be a nice little test. I know I'm compiling it every time I run it, but it's okay, it's fast. All right, so there we go. So apple, okay, apple tombstone, and then grape actually goes to this occupied slot. So I'm not sure why it didn't actually use this. Let's go back to the code and see maybe why. So get insert index is in fact supposed to check to see if tombstone is a thing. So that is very interesting. Oh, never mind. It's because I'm adding the grape before I delete the apple. So that's fantastic. So let's go ahead and make sure we add this after we delete the apple. And we'll try that out. Paste this in. And there you go. So now grape is in apple's slot basically. So I think that's kind of it. Now the last thing is obviously to make sure that this is formatted in the right way, because that's our expected output. I'll get rid of this. And then, so to do that, we'll basically just go through and iterate over all of our outputs, wherever that happens. Here we go in the print function, except instead of printing, the status, which we kind of use only for debugging, I'm going to go ahead and let's add a body to this if statement. I'm going to go ahead and just check to see if the status is occupied, because if it is occupied, then we actually, what am I doing? Status equals occupied. Then we're going to go ahead and print the data. Otherwise, we're not. So we don't want to print it on a separate line. We actually want to print it along with like a space. So I will add that in, and then I guess we'll print a separate line at the end, so it's a little neater. Okay, that I believe is it. So let's go ahead and run this. I'll paste in my data, which is gone. So let's go ahead and find it again, paste it in. And we get a whole bunch of nothing. And that, of course, is because this should be out here, not after every iteration, just because the for loop didn't have a body before this. Let's go ahead, try that again, paste that in. Orange, strawberry, that is in fact our expected output. So I believe we have finished this assignment. About 100 lines of code, pretty quick to do. I think this code is a lot cleaner than the code that we obviously reviewed last time. And hopefully you learned a thing or two by watching me do this assignment. Now, before we actually claim that we've done it, let's take a look at the test cases, because I also have access to those. So these over here are the actual test cases that were given to everyone doing the assignment. First of all, I mean, you can, I don't want to like roll the ball, we'll say, on anyone here, but like the effort that has gone into this assignment is so little. I mean, this is just random characters. Like one of these has actual words. Anyway, so let's go ahead and, I mean, I'm not going to do all of these. Let's go ahead and maybe do this one and see if we get the expected output. So let's go ahead and, actually, these might have been the actual test cases because it says your output. So this is cool. So let's go ahead and grab this test case over here. We'll go ahead and run this and we'll paste in the input, and the output is banana, orange, tomato, which is in fact correct. Let's try this like crazy long one here. We'll go ahead and clear this and run main.out, paste, enter. Now I'm not going to compare this manually, so I'll just go ahead and copy this and see if we can find it within here. And in fact, it does show up in the find results, so we know that it is in fact the correct string. And let's go, this has a bunch of deletions. Let's go ahead and try this one and we'll call it a day. So main.out, right click, paste, enter, and we get a, yeah, like 5 A's or 6 A's, and then this. Okay, cool. So that is in fact a wrap. So actually one thing I forgot to mention was that students were given 3 weeks to complete this assignment. I just wanted to throw that in there. Let's go ahead and clean this up a little bit. I will leave a link to this in the description below in case you guys want to take a look at this. If you have any questions about this implementation, or you want to, or you have some suggestions as to how to make it better, please let me know. Of course, share all of that in the comment section below. But otherwise, I think we managed to do a pretty good job. So a couple of things that I noticed while editing this actually is, I mean, for a lot of these functions, I could have definitely made them const. It's a little thing, but it's usually something that I like to do. I just forgot to do it. So obviously these don't actually modify the state, so it's fine to kind of make them const. And then the other thing was, if we're really being kind of pedantic, and we should be, to be honest, because it is automated testing, this print function prints our values, but it adds a space after every single value that it prints, meaning that if we did have something like this, well, this does have a space after it. So the expected output doesn't have a space after it, but it looks like the person who did this code review actually did have a space after it like we did. And I guess, I mean, they got, I think, 10 out of 10 or something like that for it. So clearly that's fine. The automated testing ignores spaces, I guess. But if we were really being like super, you know, serious about these requirements, we wouldn't want that space to be printed. Now, unfortunately, this isn't quite as straightforward as it seems, because we can't just do something like if I less than like size -1, then print a space, because we're not iterating through all of the elements necessarily, as in we're not printing all of the elements necessarily. You know, I less than that might not have an occupied slot, which means that, well, you know, we'll always print that space. So to be honest, the simplest kind of logical thing that I can think of is to actually do the space first. That way we'll never have a trailing space, but then the question obviously is whether or not we do it for the first iteration, right? And so what we can easily do is just have a little first thing where basically if it is not the first element, then we will do a cout with a space, and then I guess we can just set first to true here all the time, except let's like set this to false because that would be correct. So then basically what we have here is a little boolean called true that we basically we won't actually mark it as false until we run through this for the first time. Then we'll just keep setting it to false, which is fine. But the idea is that we only do this. We don't do this for the first time that we print this. So obviously we get rid of it here, right? So we add a leading space if it's not our first element that we're printing, and that way we'll never have a trailing space to deal with. So if we go back over here, let's compile this and run it, and let's try this input because I don't think we tried this one. So if I paste this in, I mean, I guess it'll be hard to say if we actually have a trailing space, but you can, I guess you can see over here that it doesn't look like there's a trailing space. And this, of course, should be the correct output, and you can see that it is. Okay, so I hope you guys enjoyed this video. If you did, please don't forget to hit the like button below. Let me know what you thought of this kind of video. I mean, it's not something I've really ever done before, so I'm definitely interested in your feedback. Hopefully this was helpful to you guys. If you have any criticisms for my code, feel free to point them out in the comment section below and have like a discussion with everyone. If you have any particular university assignments or other kind of tasks that you may have done that you found interesting and you'd like me to either review them or maybe even take a crack at implementing them, then send an email to chernoreview@gmail.com. The email address will be in the description below, and I will take a look at hopefully some interesting content like this in the future. But anyway, thank you guys for watching. Don't forget that you can check out the link in the description below to get your free trial of Skillshare Premium, and I will see you guys next time. Goodbye.